This conference will now be recorded.
Hello, all. Good morning, good evening. Am I audible? Yeah, thank you, Girish. Right, so let's start. So today's our in the last session we saw a bit on the architecture, right? We saw like some important components in the architecture, like the what is a PGA, what is an SGA, and what are its importances, and what are these components all about, right? Now we will be seeing those in little detail, right? Because we need to know the architecture very well to perform engineering activity on it. Okay, so we'll be seeing those in a little detail, and also we will try to see like what generally like how what a query tuning means. Okay, because we discussed already in whenever it comes to tuning up database, first thing what comes into picture is the architecture itself, the whatever the DBMS you are using, the architecture of that DBMS comes into picture. Then the second most important thing is the query itself, like the how the query is performing, the query which you have written, like how you can you can increase the efficiency of that query by writing a proper query. So these are the two important pillars to the database performance engineering when we speak about. So we need to choose one of this whenever we are trying to improve the performance. Like there, out of these two, generally the first part, like where the tuning happens, is on the query itself, and the second, the last choice is the architecture, because architectural tuning generally it's like little costly affair. For example, like let's say I have to increase the memory of a PGA or an SGA. It's a costly affair because whenever you are adding more infrastructure to your resources, it's the last solution which we have, not the initial solution. So initial solution always is the tuning of the query whatever we are running, right? So to do that, there are multiple ways, right? We need to understand. Now, to tune a query before we can understand what is the problematic area in a query, we need to understand, like we need to know how do we find it, like what is that problematic area? Because if we want to find a solution or if we need to fix it, okay, we need to find where that problem is. So to find the problem, we need to know some different techniques of debugging a query, some different tools of to get the logs, to get the details of whatever we are trying to test, right? So those all those things we will see, and in that AWR report plays an important role. So we'll be seeing that extensively in a whole session, like what is the AWR report and how we can use it, and like we can leverage it for our purpose. Okay, so now let's come back to the architecture part. Just a second. Yeah, so let's deep dive into that. Okay, so let me show you one example. Okay, so now we are trying to tune our queries. Last session we saw like the architectural components like PGA. PGA is a private global area, and we have the SGA, which is a shared global area. We have the disk, we have the redo log. These are the different components inside Oracle DB, and this is a very simple way of like understanding the architecture. Because if you see the real architecture of Oracle, the image will be something like this. Okay, which understanding which is little difficult because so many components, and you will get little overwhelmed with this sort of view, right? But as a performance engineer, what you require, right, that's what is being shown in this image. Okay, so this is specifically focusing on the performance engineering which we are going to do. Like what are the components which we have to look for when we do performance engineering on. So now when we try to understand the architecture, you need to know some features about the SQL architecture. So how this SQL works, right? The SQL language, how it works. So for example, in a SQL language, all the data is stored in blocks. Okay, so block is generally, we can say, the smallest unit of a database. So for what do we mean by that? We will see that in clear way what it is. uh, but yeah, so that's the smallest unit which you have. So any data which you have inside your database is stored as a block. So the block size is fixed. Like every database has a specific block size, like for example 2 KB to 32 KB size. It can be anything. So if you have a data which is stored, and if the size of the block is let's say 16 KB or 18 KB, that much amount of storage is always allocated. So whether it will be 4 KB or 5 KB or 6 KB your data is, but always one block will use 18 KB. That's the minimum which you have set. So more the number of data, it will be multiple of that block size. Okay, it's not that okay 16 KB data plus 8 KB, it will be 24 KB. No, if your block size is 18 KB, 16 and the 4 KB data will be stored in 18 plus 18, which is 36 KB of storage. It won't be like 16 plus 4 20. Okay, it will be always in the block units. So that we will see how that block unit is, generally what's a database block and what are the different parameters inside that database block. Now to understand how the query now this question might be coming in your mind, right? Like we are speaking about query tuning. So how will we do the hands-on, right? How will we understand, because since we don't have a database, right, we need a database to work on, right, to do a hands-on. So for that only, we have one demo database application which I will be sharing with you all. You have to download that. So I will just open. So there are two softwares which is two things which you need to download. One is the virtual box, which I will show you how you need to download and how you need to install as we go ahead with the course. And there is one more VM which is a ready-made VM which I have provided. You can download that VM. It's around 4 GB of memory, so you can't download it quickly. Okay, so you need to download it little upfront. Okay, so and you can just run it. So I'm just running that. I'll show you all the steps like how to configure and all, but for now I'll just run that. Right. So to log into this DB, I need to enter Oracle. That's the username password. So for this purpose, for the demo which we have, we'll be extensively using a tool called SQL Developer, right? So let's start that. So this is just a demo. I will be going very deep into these in the later sessions. So just I wanted to show you how we will be doing some hands-on and what all tools we'll be using for that purpose. So more sort of a prerequisites, okay, which you need to download and keep. Right. So now in this is my SQL developer homepage. Now in my like already I have connected 3 DBs to this developer. So I have the HR, SH and the system DB. Now each has its own tables and importances. So for example, I will go to the SHDB. I'll connect to that. Right. So now here, so there are like multiple queries available. Okay. So let's say I run some query. I'll be sharing all these documents with you all, so you can also easily play around with these things. Okay. So just I wanted to show you some example. Okay. Like something which you will understand easily. So let's say I have a query like this. Okay. So let's start from employees where employee ID is equal to 100. Now I can generate an execution plan for this, or we can say an explain plan for this using the options like which is given already by the SQL developer, which is at the top. Okay, so if you click on this, okay, so we are in a wrong DB. Let's go to HR DB. So let's run it. Okay, so now if you see after I ran the explain plan for this query, you can see something like this. Okay, so now what are these things? Okay, like there's a select statement, table access, index, and access predicates. Then there's something called a cost, right? It's showing 000. So basically this is how your Oracle is executing that statement. So what is happening first it has an access predicate. We will see what is an access predicate and all later on. Okay, so like the employee ID is 100. So that's the access predicate which we have. Then there are the row sources, we call it. Okay, what is the source of those data? That's given in the object name, then the options, and all these okay, all these like steps one by one has a very important significance with respect to the performance, because each step will add a higher load, or we can say an overload on your system. So how do we reduce these steps, and how do we like for example index is one step. So here we're accessing an index. Now rather than accessing an index, if I have some other way to do it, like some partitioning or something, so how will it improve my performance? That I can analyze easily using the execution plan. Now what execution plans, or we can say the explain plan more clearly. So we will see what is the difference between execution plan and explain plan. Both are pretty much similar, but when we see it in detail it will be more clear. So let's say this is the explain plan, okay, what we have generated. Now this explain plan, how is it significant? This is the way how your statement will be executed by Oracle. Okay, so now if I change this and if let's say cost is a parameter which we are generally interested in. It is a direct like we can say it's a direct it's directly related to the resource utilization like the CPU disk and all. So that's why the cost is very important. Okay, So that's what we will be always looking into as a metric to reduce the performance. Now the query which I have ran here is a very small query, so the cost is very negligible. That's why it's showing 0. It could be some point level cost. Okay, so that's why it's showing 0. But if you run some bigger queries, you will get a significant cost, which will be like from which you can make a good inference. Like if you're well, like after you run a query, whether there is an improvement or not. Okay, so for now, yeah, just coming back. So these steps, each of these steps will add a overhead to your resources. So we need to understand how we tune it. So to understand that, you need to know what explain plan. Yeah, so what explain plan I need to use. Okay, so like what explain plan the Oracle is using, right? If I know that, then only I can change the query and check whether by changing the query, whether I'm able to change the execution explain plan, and whether that change in explain plan is improving the performance. So to check that only, we have this tool called SQL Developer, where we have multiple ways to do that. Okay, not only one. This is one way which we saw. There is auto trace, there is $SQL plan view, and each has its own significance, like each methods. Like to get this execution plan, there are different methods. Like one is explain plan and the others are execution plans. So we will see like what are those methods. Like auto trace is there, $SQL plan view is there. And then we can use the in this explain plan view, which is DBMSX plan, right? All those things. So we will be seeing that. Okay, so this is how like our demo application will be, like we will be leveraging, and we will be seeing it in detail, like how generally, like what we will do with this uh, like how what all we will do with this query, and how generally we will improve the performance and all once we start looking into this queries in detail. Okay, so let me go back to the architecture. Okay, now to show you some example, okay, of how we can improve the performance by changing the query. Okay, so let me show you quickly one example. Like let's say I have a sales table. So let's say I write a query something, let's say select star star from, I will use sales table. Let's say this time I'll use a sales table where I'll use a where statement where, no worries. I say anyways, the queries which you will be running for the analysis, obviously you have those queries with you already, because what we are testing is already developed one. Okay, it's not like we need to write the whole query again. So SQL language, you need to know only basics, because you need to update those queries, whatever queries you have, the some other ways which way you can improve the performance. Okay, like changing some or to and all those. That's what I'm trying to show you, some basic things. So equal to, let's say I give some value 14, or some promo id equal to 33. So these are some table like some row values which I have. So I will be running that. Okay, so let's see what it is. Okay, so for this I need to go to sh, right? Now this is my explain plan. Now this explain plan I can generate in some other way also, which is more sort of a tabular view. So that way it is little bit more easy to view. So to do that, For example, what I need to do is I just need to enter explain plan for. I just need to add one extra line called explain plan for, okay, in front of whatever query I'm running. And what I will do, I will run this. So to run this, I need to click on this green color run statement. Okay. So once I run that, I will have this plan for succeeded. Okay. Now what I need to do after I get that, I just need to do select star from. I'll explain all this what it is, but for now, just try to understand the end thing. Okay, because that's what I'm trying to show now. So now you will get that same thing. Okay, now this will be little bit on the tabular view, and it's more easier to understand also in the tabular format. Now if you see here, I'll just copy this plan. Okay, I'll just copy it. I'll paste it into the notepad. Okay, this is my first explain plan where I'm using a or operator. Okay, so my query, if you see, it is using a or. Okay, using a or operator. Now what I do, I change this query. Okay, the same query, I change it from select star from sales, where product ID is equal to 14, and what I will do, I will do union all. Okay, this is one generally what we can say, it's a it's a union operator. We will speak about it later on. It's in a SQL language. Generally we use it to union two tables and all, so we'll see that. Okay, for now just try to observe how the cost is improving. Okay, so union all, then again what I will do, I will do select star from sales, where this or I will remove. Okay, so what basically I'm doing now is, I am, instead of using or, I need to use and. Okay, so that's what I'm trying to do now. So let's say select star from sales, where, so basically the result is not changing at all, but what I'm trying to do is I am changing the operator what I'm using. Rather than or, I'm using and, but the result remains same. The output of that query remains same for both the queries. So where promo id equal to, let's say, 33, that's what we chose, right? And prod id 14. Now let me run this. Okay, so I'll run this query now. So I got plan for succeeded. Now I'll run this. So now if you see, okay, right. So now if you see, what is the cost, total cost came, it's like these are the costs which we have, right? So now when I use the same query, okay, the first one was this one and the second one was this one, but both of them have the same result. I mean, if you run the query, the result is same for both. Okay, but if you run, but both the queries have different execution plan. You can see one is this execution plan, the other has this execution plan, but the result is same. Okay, and even the cost, if you see, cost is higher here. Okay, and even here the cost is lesser because it's only 491. Here it's 877. So see how the, so now out of these two queries, if I need to choose which is the better one, I will choose first one because the cost of that is less, which is 491. So what I should do, if the developer has used this type of a query in my in the like for developing the query, what I need to recommend is, you don't use that, use this query, which is the first one which we saw, right? Use that query here. Now whenever you run a query, there is something called a plan hash value which is also generated, which is basically it's the, we can call it like an address to a plan. Okay, so this hash value will be same for same plans, because can anyone remember and say where these execution plans are stored, in which part of the architecture? Where do we store the execution plan? Like in the data dictionary, this result or library, which cache the execution plan is stored, like we saw in the last session, right? Anyone remembers? Okay, no issues. So basically, if you remember, library cache is the cache which stores the execution plan. So whenever a query is executed, the second time you would have seen that the time required for executing that query will be lesser, because it to all the execution plan, the even the table schema, the result, all will be stored in different caches, and second time whenever that query will be executed, the data will be taken from those cache. Okay, so that's why. Yeah, so that's, we'll be coming back to this in detail, because execution plan is the backbone. Okay, so this is the backbone of tuning a query. So we'll be surely coming back to these in detail, but just I wanted to show you a demo, like how we generally improve the performance, and when it's a query. Okay, like when you have a query, how you improve a performance by running some basic statements and improving that using by just simply changing from and to or and all those stuff. Okay, so let me go back to the architecture. Okay, so let's come back to the architecture. Right, so now let's understand a bit more on the block size and all. Okay, so what is generally this block size, and what is its importance? Okay, let's try to understand that in little deep. Right. So how many of you are a little bit aware of the SQL language? Anyone? Like, you use it at least for some basic things. Anyone?
Yeah, Vishnu, I am aware of it little bit.
Oh, okay, Gaurav. Anyone else? Like Girish or Girish, Pravash, Arun, Karthik. Right, no issues. Okay, so let's. Okay, okay, yeah, no issues, no issues, Girish. So basically, this SQL language, the basics, I will say. Okay, so for example, if you want me to call out what all, for example, in SQL, if you know what is a or, what is an and operator, how to select some data from a table. Okay, so that sort of thing. Some little bit of like just an understanding. I will not say to write, but just an understanding of different types of we can say different types of operators in a SQL, like or and no, and then different types of joins. Okay, like just to understand like what is a join and different types of join, and what's an index, some basic things. Okay, like that, if you know, it will be far more. Okay, okay, thanks, Karthik. Yeah, so that's what. So if you know basics of SQL, it will be really very helpful for you in this course, because you can easily correlate these queries and all. But if basics you are not aware also, I will say once you learn, like let's say I ran a query, so we learned it. Okay. So after that, if you go and revise also, it's fine. It's not that like you have to learn it and keep it. But I will say better to learn with this course itself, the basics also. You can find a lot of good materials online for learning SQL language. You can pick any of those. More sort of like an overview. No need to go very deep, detailed ones. Like let's say like a crash course. Okay, take some videos which are like SQL crash course sort of thing. You can go through that just so that it will be more clear what we are taking. Okay, so yeah. Like right. So now before I go to the Oracle SQL Oracle architecture, so what I thought is let me quickly, like, very basic, okay, like in a very basic way, let me cover little bit of the SQL architecture also. Okay, so generally, like, what is a SQL, how does a SQL architecture looks like? Okay, so I thought, okay, let me cover that a bit so that it will be useful for many of you here, because it's also a little common database management system, right? So I thought, okay, let's understand a bit on the SQL server also. Okay, how a MySQL server looks like, and how like how we can understand that. Okay, so let's try to check. Let's try to see. So now we here we have a MySQL architecture basically. So MySQL is again a relational data DBMS. Okay. So can anyone guess, like, what is this relational DBMS? It is one type of a database management system, but why do we call it relational? Even
Uh,
Oracle is a relational DBMS. Yeah.
so I think the relational database, you fetch the data in a hierarchical way, whereas SQL, it's in a structured query language, so its data is stored in a structured manner. So the relational database basically is fetched in a hierarchical form.
Yeah, correct. So let me put it in a little bit more easy way. Okay. So how it is, like, for example, if you have a data like a tabular format. Okay. So it's more sort of like a relation. So like, for example, if there is a student, then the student will have an ID, a name. So an ID and the name, whatever I have, the parameters like the student ID, student name is related to the student. Okay, so in that way all the data is stored like a relational model. Okay, so that's why it is called a relational database. Now there are some other DBs like time series DBs are there, non-relational DBs. Okay, so we call it because there is no relation with what is at the top. Like, it's not like a tabular format or something. It will be some other ways. Like sometimes it will be like you would have heard, like, even there's a blockchain, right? So there are different ways of arranging a data. So a relational way of like a tree, or we can call it like correctly pointed out by you, like we can say more sort of hierarchical format. Okay, it's called a relational database, and it is a very proven database even today. Okay, it's like it's very easy to access the data and faster, and and suffices for most of the applications. But there are some applications which like require more sort of time-based data. Like for example, there are graphs, or you need to analyze lot of data which is time-based. So for those purposes, you have a lot of time series DBs. Okay, like if you'd have heard, there are influx DB. There are different time series DBs which are useful when there is a lot of data accumulated, or we can say related to that. Okay, so that time we come to the time series DBs. So now coming back to MySQL architecture. So MySQL architecture is a relational DBMS. Again, like Oracle DB, this is also relational DB. Only main difference between MySQL architecture and Oracle is it is an open source. Like it's, you don't need to pay for this. Okay, it's an open source software, and it is also supported by Oracle. Okay, so it's not that it's different. So it's also supported by Oracle, and it is again fast. It's very scalable. Okay, Even it supports many operating systems like Windows, Linux, Mac, and all, like Oracle, similar to Oracle. So that's why it is widely used, because so many good things about it, and it's totally free, right? So that makes it a very good choice for people when it comes to DBs. So now if I try to understand, okay, like what language it uses, again it uses SQL language, right? SQL to manipulate the queries and all, to manipulate the data, retrieving it and all. It uses the SQL language. Now let's try to understand the architecture. So in MySQL DB architecture, you can divide it into three important parts or components. One is the client, the server, and the storage layer. Okay. So now, basically, this type of architecture is called client server architecture. So basically, this type of architecture is called client server architecture. Even our Oracle DB is also similar to this, right? If you compare it with Oracle DB, we have the PGAs and all, which is the client side, and the server side is basically the SGAs and all, right? So it's more sort of a client server architecture also. There too. Okay, it's not much of a different. So now what happens in this client layer? Okay, so client layer basically is the top, like it's a more first layer which any query or any action or any task will encounter. Okay, so the client layer, which is this one, the client layer is basically, it gives the instructions to serve. Okay, so basically whenever a query will be entering for any session or something, like similar to the PGAs and all, right? Whatever queries are coming, the client will insert or will hand over those queries to the server. That's what the client will do. And obviously, see, the query will be coming from different sources, like it could be JDBC, PHP, Python, so even some plugin, okay, which is doing that purpose. Okay, so those things, everything will be handled by the client, and that will enter into the server. Now when the 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 server or whatever activity I'm trying to do, when it enters into the server, first it will enter into the connection handling. Okay, so whenever a client is sending a request to the server will accept that request. Okay, and that client is connected by this connections component. So like the connection, so until this connection is not established, your uh, whatever query or whatever action you are trying to do will not enter the server. Okay, until when the connection is established by this connection or thread handling, only that query will be added into the queue for processing. Until that, the query will be waiting here outside the server. Okay, so this is the initial entry point, or we can say the entry spot where my query enters the server and is allocated some resource to for a DML operation. Okay, we can call like that, we can say like that. So yeah, so next we have multiple components like the query cache, parser, then the table metadata cache. Each have different activities to perform. Now, for example, in Oracle DB, when we were seeing, we haven't reached something called the optimizer. We will be reaching those soon. Before that itself, we are covering for the MySQL. That's fine, not an issue. Just a minute, my tab is stuck. Let me draw it and show you. Okay, so now here, if I show you, So now the connections is the first part which it will enter. Then we have the parser. Then we have the query cache and all those stuff. Okay. So now let's say, now let's try to understand what is the authentication. Okay. So generally there is some authentication also which will happen in the server side when the client is connected to the MySQL server. Okay. Now this authentication also is taken care by like it's also taken care by the connections or the thread handling part. Okay. The security features, all the security related stuff will be handled by the connections or the thread handling part. Then in the server layer, now when we focus on the server layer totally, okay, now this layer totally, when we focus on that, when we speak about thread handling, so thread handling, which is this one, that part, okay. So thread handling part, what it does is it will accept the request first of all, and it will connect the client. Okay, that's the first activity which it does. Then it's also keeps that connection alive. That's the second most important thing it will do. Then the other thing is it will allocate proper, like the threads, right? How many ever threads are coming, it will take it in batches, like 100 threads or the 500 threads. Like for example, how many connections you want to keep alive. Okay, so those things it will handle. And also the queries, like which is being executed by those threads, it will handle that module also. Okay, so that's what is handled by the thread handler. Now what is a parser? So parser is some sort, like it's a, so you can say the sort of a software component, okay, like a software algorithm we can say. That is basically like what it does is it generally what it will do is it will break the like it will try to understand the table schema, whatever is coming, okay, whatever query we are trying to run, to get that the semantic analysis and the syntax analysis and all those, that will be done by the parser. Now for example, if I'm executing a query, right, and if the query syntax is not correct, okay, this parser will throw error. It will not go to the optimizer. Before it enters the optimizer itself, my query will fail, and my client will get a failure message. Okay, so that's a parser. Now optimizer, what it will do is it will try to optimize that query, whatever it is getting. Once parser is successful, it will enter into optimizer. Optimizer, what it will do, it will try to optimize that query. Like for example, instead of and, if I use or, those sort of things, okay, it will try to do with the query to optimize those queries. Then again, similar to our Oracle cache, there is a query cache in MySQL DB. So query cache, what it will do, it will store the complete result set. Like for example, what the results, like the even the execution, the parsing, the optimization details, then all those details it will store in this query cache. Similar to our SGA, we can say, okay, the cache. Okay, and again there's a buffer sort of thing, which is the storage engine buffer and cache. Similar to Oracle DB, this is, you can relate it with the buffer cache in Oracle DB. Okay, the same thing happens in the storage engine and buffer and cache. Then there is something called a table metadata cache. This one. Now this metadata cache is a, we can call it like a reserved area of memory. Okay, so what it will do is it will be used for tracking informations on databases, indexes or objects. Those sort of things will be stored here. So maybe we can call it more sort of the table schema, right? So when you compare it with the Oracle DB, this table metadata cache, with what can it be compared in Oracle DB? Any guess? Like it stores the table schema, okay, like the table related details. So what cache could be?
Data dictionaries.
Correct, great, the correct answer. So it's more sort of, it's acting more sort of like the data dictionary cache. Okay, so that's what this table metadata cache does in the SQL server architecture. Now there is something called a key cache. In key cache, basically the indexes are stored. Okay, it's the most important thing, like the index data is stored inside the key cache. By default, even the query string the resource path, and all those details also sometimes stored in key cache. But the most important thing what is stored in a key cache is the indexes, whatever available. Now after this components, which is just server layer, okay, there is something called a storage layer. Okay, so storage layer is more sort of like it's, you can call it like there are different types of storage engines. Okay, now what is the storage engines? You can say it's more sort of like you have a data, okay, and I created that data in a InnoDB, or let's say if I created it using the small memory or my ISAM, there are different storage engines. Okay, now if I created those data, right? So storage engines are more sort of to transport your data from one place to another. No, these storage engines are useful. Like for example, you have a data, you can plug that storage engine to the MySQL DB. Okay, and that MySQL DB can, it's more sort of the disk only. Okay, you can say it in the Oracle DB we saw, right? It's more sort of a disk, but there are different types of disk architecture. Okay, like the InnoDB, MyCM, and NDB memory. We can call it more sort of the disk management. Okay, what they are using. So these type of storages you can easily plug in to the MySQL DBMS, and that data can be accessed by my MySQL architecture. Now the storage engine, what it will do is um, uh, so whatever data you have, you can easily transport from one place to another by using the storage layer. So these are the different types of layers inside the MySQL architecture. So you have the client layer, you have the server layer, and you have the storage layer. Now all of this will together constitute the total MySQL architecture, and it is very much similar to the Oracle DB architecture if you try to compare with each other. Like the multiple components are being the even the flows are common, but yeah, you might not see some things like the redo log. You might not see here because see, Oracle is a paid thing, so there are some things which are extra which are not there here. But yeah, most of the things but is there, and frankly speaking, it's a very good DBMS with respect to open source feature. Okay, because it's an open source tool, but still it's very much more efficient compared to other open source DBs which we have in the market. Even there is a rollback available in MySQL, but there are some plugins which we need to install. Rollback features are there. Even if you speak about the memory efficiency, okay, MySQL DBs have very low memory leak problems. So if you have some memory leak analysis, if you do on the MySQL architecture, the memory leaks are far more lesser compared to Oracle DB. Okay, with that we observe because of its less complexity. Okay, Oracle DB is little complex because of its yeah, that complexities are due to its wide variety of things which you can do with that DB. But yeah, with the complexity, there are some other cons also which are coming into picture, which is mainly the memory leak issues and all, which you see more in the Oracle DB than MySQL DB. Okay, and again, even like even using some partitioning and all, you can make MySQL DB more and more better in performance. But yeah, again, it's a open source tool, but so bigger organizations, when they grow, they automatically move on to Oracle DB due to the support and all. Okay, like there are a lot of good support by the Oracle team. In MySQL, what happens is it's a community which you will get help from. So it becomes a little difficult to get those. Okay, so that's why. Yeah. So any question, anyone?
Hi Vishnu, Arun from this side.
Hi, Arun. Yeah.
Vishnu, I have a question. Is just see, it's a nothing to related with that, but I have a question on that. See,
Okay.
whenever I'm just some search button, some search field is there, okay, and in that search field, when I'm just entering some name or something like that, And in
Okay.
that time, I'm just looking that it is taking more time. Is that circle is moving here and there, here and there. The circle is moving, right? I don't know
Yeah.
what is the name properly called it is. But
Mhm.
if you are going to ask to somebody, then why it is taking more time? People are simply they are just using a word. Performance testing is not happening for that. But see, I'm
Yeah.
just single user. I'm just a
Yes.
single user. I'm hitting that one, but it is taking that much of time. But
Mhm.
in your DB the database, if you are going to ask any database person, that person is also going to use a simple indexing may be not happening, right?
Yes.
Maximum DB people they are going to use that particular word. DB indexing is not properly happening. That's why it is taking more time. But could
Correct.
you help us to find out for what reason? I don't know the exact reason, but what are the possibilities are there, so that we can find out these are the points. Maybe due to that reason, it is taking that much of time. Because
Great.
I'm just hitting a single user, only a
Correct.
single user hitting it there. It is
Yes.
not required at all. Your performance testing right now.
Correct. Yeah. Yeah.
That's
So
why.
that's
Yeah,
That's
please.
a great question, Arun, because it's very common one also. Because when you have a search, like when you're searching something, okay, what happens generally is search is a very cost-intensive operation. Because why search is cost-intensive is because when you're searching something, you need to find it out through whole table. So that's why what you need to improve that, like to get the faster search. So what is a way? Like for example, in your house, you need to search something. Okay. Like for example, I lost a mobile, or I want to search my mobile phone where it is. Okay. Let's say I have a room full of things. I need to find mobile from there. So first thing, what will I do when I search? I will try to remember where it was. Right. So what I'm currently doing, like what I am doing currently, is like I'm filtering out the places where my mobile will not be there. Okay, by remembering, like for example, if I have a dining table, I will say, okay, I won't keep my mobile on the dining table. It will surely be on the laptop table, let's say. So I am filtering out, so I am filtering my data from dining and all those stuff to just the laptop table. So now when I now searching inside in the laptop table is far more easier for me, because it's a small area. So compared to the whole house. Okay. So similar thing happens in the search also. Whenever you have a search statement, okay, first you need to do, what you need to do is you need to ask the DBAs, or if you don't have access to those queries, you need to ask the DBAs what query they have written for that search statement and how they are executing it. Okay, now in that queries, they should have a proper filtering also. Like for example, if they do select star, directly select star from whatever table they want to pick the data, and they just give where and whatever search term you are trying to search. If they give that, it's a wrong thing which they are doing, because select star, if your table is like some 1,000 rows, what it will do is it will search the whole 1,000 rows for that keyword, which is not a correct way of doing it. So that's why first you should access an index. Okay, so whenever you have a table, if the proper indexing should be there. If you have proper index, it's more sort of like a postal, right? The pin code. If you don't have a pin code in your letter, then finding that house is very difficult for the postman. So index is also something like that. That pin code, so every data in your table should have proper indexes. Now that first you need to check. Okay, second is your query should be accessing the data using those indexes. It should not access the data directly by just whatever search term is there. You select star from whatever table and you're searching that. No, you should not do that. You should write a proper indexing statement in the query, where that data should be accessed using those indexes. Now, if let's say your search statement is such a way that you need to join two tables, then what type of join method you're using, that also matters there, right? So ultimately the query, what they have written, you need to analyze, and how much time it is taking, and how you can optimize it. Getting my root? Getting my point? Now
Yes,
this is
Vishnu,
as
I
yeah,
got it. But as you said that if you are going to take to search a word in dictionary, if you are
yeah.
not implementing your indexing talent, so that it is
Hmm.
very difficult to find out the particular word. If you know the indexing, so that you are going to search a word, automatically you are going to take the first word of that, first letter of that, then you are going to search that particular
Yes.
word, then according to that you are easily find out that particular word from the dictionary book. Similarly,
Yeah.
maybe there is some optimization is there, how the data DB person they are going to write their queries.
Correct. Yes.
Instead of as you said the select star from, it means that it is totally going to search the whole table instead of what is our requirement.
Correct. Yes. So that's why. So whenever you get such a issue, what you can show them, you can run that query, and you can what you can do is you can extract the execution plan for that, and that cost should be what I am expecting from you. What you are saying is that cost will be very high. Okay. So now what you can say them is this cost is very high. Now try to reduce this by improving the query, because let's say you are into engineering or like testing, so you can't write different types of queries for which they are very experts in. So let's say you don't edit the query. What you just do is you give this execution plan to them. You just say the cost is very high for this. What you need to do is you bring down this cost to considerable level.
First you are trying to use the word for your response time, right?
Correct. Yes. Cost is more sort of it has CPU, it has disk, it has response time, all included in one parameter.
Okay, you are just trying to say that the resource utilization part.
Correct. Correct. Yes.
Okay.
Vishnu, this is Gaurav here. I have one question regarding this regarding this table which is coming. So how do we get this table? Like, I mean, this execution plan. How do we get this?
Yeah. So no worries, Gaurav. No need to get confused. This one I showed very quickly, just like a demo. I will be going very deep into this. Okay, like how to generate and different methods of generating this table and all. That time it will be more clearer for you. So for now, this is just I wanted to show, because we are again and again saying what is an execution plan, what is an execution plan. So I wanted to show you what is an execution plan. Okay. So so that confusion is not there. You can visualize what is a generally how does an execution plan looks like. But I will go deeper into this in the coming sessions. We will see different methods of generating this table. It's not one method to do that. There are multiple methods to do that based on the query, based on the type of plan which we are generating and all. Okay, so that we will be seeing.
Okay.
Vishnu, I have one question. So this
Correct.
cost is the right percent CPU. So
Yeah.
what are all that's considered, and how this value helps us, and what is a good value there? I mean, we can say that it's performing better, and what is bad value? I mean, is there any
Yeah.
threshold? Or,
So this cost also we'll be seeing very detailed, because that's what is you are going to analyze and you are going to improve, right? So for that you need to know what is this cost, like how is it getting calculated. Now to say it like an overview, what all is included in cost: CPU cycles are included, IO operations are included, disk operations are included, and even the block read write. Okay, we will see what all those. Now these are basically cost. When it comes, we can say cost is directly proportional to the resource utilization. Okay, so more the cost, more resource that query will use. So if you want to reduce the cost, so how much is permissible? It's more sort of the query, how much big the query is. So it's not like we can say, okay, 877 is high, or 1000 is high, or 5000 is high. It's more sort of how many times that query is being called, okay, and how much it is taking. So based on that, it will be you will have to decide, which we will see. Like what is high, it's more sort of a relative term. Okay, so cost is more sort of relative based on the other queries which you're executing and the SLAs what you have. Okay, based on that you can derive a percentage what should be the cost.
okay.
Yeah. uh, any other question, like Girish or uh, Pravash?
And Vishnu, could you move to that architecture, please?
Yes, yeah.
And in that architecture, what you have shown here, that is connection and thread handling. Okay,
Yes.
it is related with the connection pool.
Yes, it's more it's related to the connection pool, because in MySQL configuration, right? If you see, if I can show you some config file, 1 minute, I will show. If
Because
I
as I know about that maximum issue, whenever you are going to get such type of issue, that time maximum performance test
correct,
engineers they are just going to the see about the connection pool, and that
Mhm.
connection pool, they are able to see about your active count, available count, and most probably in use count. These are the
Correct,
three
correct.
factors they are going to see. Is it related with that one?
Yes, yes. Let me show you one MySQL config file. Okay, it will be
Please,
clear for
please.
you. Yeah, one
Yeah.
minute. I will show you that. Though it's not related to this course because it's MySQL, but I will show you because since you asked this question, it's better that you can visualize that. Okay, how it is generally how this config file looks like. And let me open one server. Just I'm logging into that server.
Yeah, it will be better to us to see means how many active connections are there and how many connections are available, and how many connections are getting currently used. That is a basic part we need to see.
Correct. So basically, you always have something called uh, it's like there is a MySQL config file which you can easily find out, or even the DBS can give you what they have set. That you can find inside the server. Just a second. I'm just opening that. Yeah. So see, there is something called a in the instance whichever you are in the etc folder in MySQL there is something called my.cnf file. Okay, so that my.cnf file will have different MySQL configurations. So in that, what you should be very much interested in is let me show you is something. These are the parameters which you should be more interested in: the max connection, the vmax user connections, the vwait timeout, the interactive timeout, and display errors. Okay, so now these max connections is where the connection bottlenecks come up. For example, now if you're running some 100 user test, okay, now there what max connection I have set is 40. So now what will happen? Any guess? Like if I'm running for 100 users, if 40 is the max connections which I've kept.
The
Then
other
automatic.
connections get suspended, right?
Correct. So other connections, what will happen? It will remain in the pool. I meant you will not
Yes.
get some error or something. It will be waiting, but okay, it will not get the data. It will wait until that 40 is done. It will then only the next one will start. So there will be a lot of time delay in between, and that you can easily see in your response time and all. But again, one more thing. Now there could be timeout errors also, because what happens is this timeout settings are also there which are set. Okay, like for example, if your request is taking more than 5 seconds or 6 seconds, automatically it will time out. Okay, so now due to this waiting, timeout errors will also come. So that's why whenever you get those type of timeout errors, or like your response time is increasing due to the waiting of getting that response back. Okay, so that means that time you need to check the MySQL configuration. Like you should ask the DBA to provide you with this MySQL configuration. You can see that what is the buffer size, what is the allowed packet size. Each has some or the other significance, but majorly this is the part where we are more interested in the performance engineering. So how many max connections and user connections, and why this much? See what happens. Can I increase it to whatever number I want? Any guess? Like, can I keep it to some 4 lakh or 5 lakh connections? What will happen? What will be the consequence if I increase this?
Maybe you will provide some more cost for that.
Correct. So if you give some 4 lakh or 5 lakh, okay, more the number of max connections I am giving, though that connections are not being used, okay, but a specific amount of memory will be allocated for that. So if I give some 100, 500, if you see the, if I go back, I see this is a server, simple server, which is mine. Okay, for my experimentation, I have created this. There are different, like you have the Apache server and all. So to play around, I created this. So now here in the there is something called memory. See, Now it's taking around 9 GB or 9,000 MB of memory. It's being utilized by the database server, which is a MySQL server. Now this memory will increase if I increase the max connections. Now that memory is the memory allocated for the database server. It's not that it's using that. Okay. So whenever a database server is created, automatically some amount of memory it will allocate for itself. Okay. So that much amount of memory will not be available for anything else. So more the max connections, more it will be, like it will increase. Now this is the case with anything. Even Apache, this is a web server which I have, right? It has 284 MB which is allocated. Even reverse proxy server, it is 28 MB which is allocated. So any service which is running in your instance or in your host machines, some amount of memory will be allocated for that service, and that will fluctuate. Like for example,
So,
it might decrease with that. Yeah.
so Vishnu, you're saying that this memory will be locked and it will be not allocated for any other process if requested.
Correct, correct. So that's why this max connections also your DBS can't go any number. Like they have a reason for justification why they have kept it 100 or 200. So so either they have to improve the timeout by improving the process or reducing the query time, because like your 100 query, let's say your max connections is 100 and your SLA is 5 seconds. Okay. Now what will happen if you hit with a 300 user or 500 user load? So the 400 users will be waiting. 100 will be 100 the users, like the query of the 100 users will be getting processed. So that processing should be fast. Then your SLA will be under 5 seconds. So these are the options which they can play around if they can't improve the max connections or they can't increase the max connection. The other option is only to improve the query performance. These are the two ways, okay, to do that. Yeah, so let's going back to that.
And Vishnu, there is also some possibility between the connection pull leak also.
Um, Generally, it will not. That's a little advanced thing. Okay, it's a
Because
DB.
see, if you are taking 40 connection on that, and
Yeah.
some of the objects are just going to capture that particular some of the connection, they are not going to release that one.
Correct. Yeah.
It means that what happened, your connection is going to lower.
Yes, yes. Yeah, some actually there are some scenarios where the connections will be in block state due to some deadlocks and all. That is there, but that we can't call it like a leak. Yeah, but as you correctly pointed out, it's more sort of it's not releasing and all due to index issues, or it's keeping on into a loop search, because generally what happens is some data is there and it's not, it might get into a loop search. Those things also happen. Yeah, that's obvious. So that time what you need to do is you need to flush all the threads which are running. Like you need to do a stop event, okay, and you need to restart. That's what is that's the option which you need to
Means
do.
that stop the world you are going to use on that.
Correct, yes.
It means that that time no thread can do any type of
Correct.
activity.
Yeah, or either what else you can do is, though it is a very what I can say, it's not the final solution, but yeah, you can always restart your database server. Once you restart your database server, automatically the threads which were in the pool will be resetted.
Vishnu, that is not a solution. It means that see, you cannot that you are going to provide on your observation, but it is not a solution on that.
Yeah, correct, correct. It's not a solution. Yes.
Yeah.
Yeah. So basically that whenever these release issues and all come, no, it will be more sort of issue with the indexing or the query. So that they have to look into, the DBS have to look into and find out why that issues are coming. But these release issues you can easily find out from the AWR report. Okay. So AWR report, if you find out and if you get the active sessions. So if I show you the AWR report quickly, this is more sort of an overview. Okay, don't no need to be overwhelmed by all this stuff, because what I am now currently showing is like an overview. We'll be going into all this in deep. Okay, it's not that we'll because that's all this course is about, right? We'll be going in all this in deep, but even AWR, what I'm showing now is just a
Vishnu, also can you, sorry to interrupt, also can you discuss on how to find memory leaks and thread dumps, all those things, those two things? Can you cover those things as well?
that is more sort of performance engineering, not in database, the garbage collection and all the GCs and all. So that is not covered here, but if you want, I can, but that is not related to DB, I will say. It's more sort of the JVMs and all. No?
Yeah,
It's
just
little different.
can you just explain it little bit in this course as well?
I can, but maybe by the end of the course.
Okay, sure,
Yeah, yeah,
sure. Okay.
But database
yeah.
log you can explain, right, Vishnu?
Sorry, what Arun?
DB logs you are going to explain on that.
Correct, correct. Yes, yes. DB everything will be covering. That's what our main objective will be. This JVMs I will, because it's not in this, but yeah. Anyways, if I have time, I'm happy to give a small overview on that. So what is like generally what happens in GCs, different types of GCs and all. Yeah, I can give a small session on that. Okay, so let's move on. Okay. Any question, guys? Anyone like on the?
We are showing yeah, AWR report something that active count.
Yeah, yeah, yeah. I'm showing that now.
Okay.
Yeah. So basically, in AWR report, no, AWR report is a very big report. If anyone has seen it already,
I saw that one, but it's a
okay,
big report.
correct, correct. It's a very huge report,
Yeah,
but
in
what
HTML format it is coming, right?
correct, right? It's a huge report, but many will not say this to you. I meant you might not find this easily that for performance engineering you don't require all those. Like in that report there are many sections. You don't require all those sections for performance engineering. You need only specific sections of those which you need to analyze for the for finding bottlenecks. Okay. Now in this there is something called top time model statistics, operating system statistics details, and also there is something called the load profile. Now using these two, you can easily find out if there is some active sessions which are being created by not getting released and all. No, those issues you can easily find out using the time model statistics, operating system details. If I show you quickly, yeah, I don't want to go very deep into AWS because it's totally one session we require in this. But just I wanted to show you those details. You can easily find out how many active sessions are there in your DB, and all those details you can get from the AWR. Okay, we will see how we come into that number, how we calculate it using the database time elapsed, and there's a formula for that finding that. Okay, we will see that when we come to AWR. Like different things are there, and what are the importance of these, all of these, right? We will see those. Okay, when we come to this, I don't want to jump into this and overwhelm everyone, but yeah, we will come to this. One whole session will be dedicated to AWS, so no issues, no worries, we'll come to that.
Vishnu, from this AWR report, we are able to find out to the high time consuming queries.
Yes, we can, because there is something called top 10 foreground activities and all. But see, again, for that, what I will say is better is to watch out for, you can easily, but more, I will say more better way to find that one is easily to use a monitoring tool like New Relic or something, whichever you have. Because what happens is here you will get some reports which are like not that, it will be like you will feel like some it's a little hard if you have some thousand queries and all, but you will get, see, now there are these are some reports like SQL ordered by CPU time, SQL ordered by elapsed time. You get different queries, right? But you can easily do that with the monitoring tool also, which you have. No need of AWS report for that. AWS report is little bit very detailed. You don't need to jump into that as soon as we are just starting to analyze. So what you can do is go to New Relic or Grafana. Which monitoring tool you have, Arun, currently in your project?
Yeah, you will use Dynatrace for that.
Okay, yeah. So just a Dynatrace you can use, you can order the queries in a higher level, and that query you can pick up and put it in the SQL developer and generate the explain plan, and you can analyze. That's, I will say, the most easier way, okay, rather than directly jumping into AWR, because AWR is little deeper analysis. When you can't find out any solution in this direct approach, right? Okay. So yeah.
Yeah, hi Vishnu, Girish here.
Yeah, hi.
I mean, I had a question. It is not specific to what you covered.
Okay.
But what I wanted to check is, I mean, being a performance tester or engineer, generally what we do is we either perform, single user testing or, load testing and get the, stats like either AWR report or,
Yeah.
you check the logs and get the SQL that is poor performing, and then we
Mm.
check the explain plan and say that okay, this doesn't have full table scan or this doesn't have an index and all,
Correct. Yeah.
and we just share it with development team for query tuning. I do agree that from tuning perspective it takes a lot to learn, and it's not a single day job because each of the parameter what we have in Oracle, if you
Mm.
change one parameter it will affect hundreds of things there, right? So but what I wanted to check is, from this course, what is the takeaway that I have? Sorry, I joined little late on the first session, so
Okay.
I could not even look into the recording for the first 30 minutes. But
Okay. Mm.
what is that I take it out from this session, which would either is it something like I can suggest query tuning, or what is it? I mean, what are the key takeaways from the course?
Yeah. So basically, now if I divide this course, Girish, so now, like for example, you are already aware, let's say you are aware about AWR, what is execution plan and all. Then let's say around 25 to 30 or 40% of the course is all based on that. Like because see, everyone is not like this course is more sort of performance engineering. So we are not assuming that people know how to get those data. Okay. So first is getting those data. How to, so next is analyzing, and then is the recommendation. So that's how the three stages of this course. So first is getting the data, like then to analyze, then to tune. So in tuning, what if I specifically speak about like what all you'll be getting or you'll be seeing with respect to tuning is like some different. I will say from my experience, okay, what all tuning recommendations I give generally. Okay, those we will be seeing. Then how to use hint. Anytime you used hint, Girish, hint operators,
Yeah.
right? So how to use different hint operators, that we will be seeing. Some like let's say some join is there, like rather than hash join, if I use an inner join or some, so that sort of recommendations. Like by seeing the query, instead of or I should use and. So those some of those different types of tuning we will be seeing, okay, one by one, like different operators, hint operators, like for example in one hint, how to use a or hint operator or an and hint operator, or let's say my execution plan is using one index, for example, some and instead of that index, I want to command Oracle to use another index, like or a join, like nested join I need to use, okay, rather than hash join. So how will I command Oracle, right? What are the operators I need to use there? Those things we will be covering with respect to tuning, because since you are focusing on that.
Okay. Okay.
Yeah. Mhm. Yeah. Okay. What's the time? Yeah, it's 9. Okay. So let's see what is this blocks. Okay. Let's quickly complete this, and then we can stop for today. Just I'll be completing this. Is my pace okay, or do you feel it is little fast or something? you can always call out, okay, and so that I can adjust my pace if there is an issue, or you're not getting, or you're not understanding something. Is my pace okay? I don't.
Yeah.
Okay,
Vishnu, we can hear. No
yes.
problem.
Thank you, Arun. Yeah. Okay, so let's come back to our block. Okay, so now in block, now we saw, right, like everything in the database is represented by a block. So let me draw. So let's say this is my block. Okay, now what is the importance of this block? Let's try to understand that. Now this block is further divided into different sections. Okay. Now this block has different sections like the row header, column data, and all those stuff. Okay. So now let's try to understand what are these, like how these database blocks are divided, and what is the significance of these blocks. Okay. Now this block generally is between 2 KB to 32 KB. Okay, so that's what generally a block size is, 2 KB to 32 KB. So this block size is set by the DBAs or when this database is being created in that config file. Okay, and this cannot be changed later on. So generally default is 8 KB. If you don't put anything, default value is 8 KB. So your block size will be generally 8 KB when nothing is being when no values are being like you don't specifically specify any value. Oracle will automatically take 8 KB as the standard size. Now this block, now the group of blocks, okay, will create extents. So extents are nothing but it's a group of consecutive blocks. Okay, and it's again for storing some specific type of data. Now group of extents are called segments. So group of blocks is extents, group of extents is segments. So segments are nothing but let's say it's tables or indexes. Those type of data is called segments. Now there is something called group of segments is called table spaces. So table spaces are a very huge entity. Huge entity means like it is bigger. In this table spaces there can be multiple tables. So in one table space, multiple tables will be there. Basically multiple segments will be there. That's what is table spaces. So from block you have extents, from extents you have segments, from segments you have table spaces. In table space there are two types of table space. One is permanent and one is temporary. So in temporary data is stored. In permanent data is stored with respect to the table space. So now coming to the block. Now this block is there, right? Block has different components. So if I take a single block, okay, there it can be divided into a row header, okay, and a column data. So this is basically the block, okay. This total is a block. Total is the block. So I have the row header and the column data. Now if I focus on the row header part, in the row header part, there are multiple subsections. Okay, so what are the multiple subsection in that? Okay, in the row header, we have the row overhead. Yeah, sorry. So here, rather than saying it like a block, okay, it is the we call it row block. It's a row block. I will explain you what is this row block means. Generally, it's a row block. Okay. So in the row block, there is a row header. Okay, basically the row overhead. Okay, then then we will have the number of columns. These are the details. Okay, the row overhead, then the number of columns, like how many columns are there in that row. Then we will have, if it's a cluster, okay, we will have the cluster ID, cluster key ID. Okay, and if there is then there is a row ID. Okay, then there is yeah. So these are the components inside the row header, mainly the row ID. Okay, now in the column header, column data, we have first we have the column length and column value, right? So this is a row block. So now if I divide this, so my row header is this much and this is my column, right? So I have the row ID, the column value. Now what is this, right? You need to understand what is this. So now let's try to visualize this like a block. Now let's say I have a database block. Okay, so I have a database block. So this is a, let's assume this is a database block. Now that database block will have multiple row headers. Okay, now this is a row block. This is a row block. This is a row block, and this is a row block with different sizes. Okay, this size will change. Now what is a row block? We saw the row block is constituting of these many components, right? Now inside the block there are multiple row blocks. Now when I draw this, I have specifically left some gap here. Now what is this gap? Anyone, any guess? Now here there is no gap. In this row block there is no gap. Here I have a gap. Any guess? Yeah, so basically see when
Column block.
not like that. So see what happens is, now these row blocks have some size like 4 KB or some 6 KB, right? Some 8 KB. Now this total size is defined. Okay, whatever, like some, we have our block size which is 8 KB. Let's say my block size is 8 KB. Now the row block can be lesser than that. It could be 4 KB or 6 KB. So whatever is spending, like for example my row block size is 6 KB, then I will have some white space after that which will be equivalent to 2 KB, because 6 plus 2 will be 8 KB, which is the total size of my block, which I meant the row which it can store, right? Now what will happen if my row block size increases to 8 KB? I have 2 KB extra, right? So it can grow. It can grow. But can this block grow? It's already full. It's already 8 KB. Now if I add more data to this, can I write more data to this? It's more sort of writing a data only. Okay, like these rows are used for writing a data, like whether the data is long or int or whatever. Based on that, there is a size, right? There's a size acquainted with those data, right? So if I try to write that data here, can I write it? No, right? Because I am exhausted with that because 8 KB is done. I can't write more data to this. So what it will do, it will create a new row block and write that data here, not onto this. It cannot write because it's full already. Getting my point?
Yeah, Vishnu.
Yeah, I
See,
guess.
whenever you are going to take a copy on that, in that a copy contains different pages are there, right? In that
Mhm.
particular page, is some width is there. After that, you can write extreme of that, right? Then you are coming to the next line. I think in this way you are just going to explain this row and blocks.
Correct. Yeah. So no issues. I guess maybe I'm rushing through this. We can take it in next session. Okay. I will start these blocks again because there are some other things which I need to explain. Maybe that's why it's little going. And it might be confusing. So I will take that from like next session onwards. We can continue from block. So we can stop today here. So any question till now I can take or we can continue in next session. Okay, yeah, then let's stop here for today. Let's continue in tomorrow's session. Yeah, thank you all and have a good day.
Thank you, Vishnu. You too. Bye bye.
Yeah, bye bye.